Okay, you know the story, right? We've all seen it in the movies. Some super smart AI just wakes up, decides humanity is a bit of a problem, and boom, takes over the world. It's great drama for sure. But what does the actual research say about this thing they call the AI singularity? Are we really heading for a collision with a machine mind that's going to leave us in the dust? Or is the whole idea just, a sci-fi pipe dream?
Well, that is the core question we're diving into today. And believe me, this isn't just some casual chat. It's a really deep disagreement between the experts, the people actually building this stuff. You've got one side that's questioning the very definition of intelligence, and another side that's busy drawing up a potential roadmap for how this, intelligence explosion could actually happen.
So, just to make sure we're all on the same page here, this is what we mean when we say the singularity. It's not just about an AI being, a little smarter than us. The key idea is that it gets so smart it can start improving itself. It's like a runaway train, a feedback loop of intelligence that just keeps accelerating, getting smarter and smarter, way beyond anything we can predict or, frankly, control. Okay, so here's the game plan for today. First, we're going to quickly define what we even mean by AI in this context. Then, we'll dive into the two big competing ideas. One that says the singularity is basically a fantasy, and another that's laying out the blueprint for how it could become very, very real. By the end, you'll see why this whole debate isn't just some far-off idea. It has real implications for right now.
All right, let's dive in. Before we can even start talking about a singularity, we've got to clear something up. What kind of AI are we even talking about? I mean, that term gets slapped on everything these days, right? Luckily, a researcher named Pei Wang and his team gave us a super helpful way to think about this, breaking it down into 3 different flavors.
So you've got AI-1, which is basically the human duplicate from the sci-fi movies. Then there's AI-2, that's pretty much all the AI we have right now, specialized tools that are really good at one specific thing, like recognizing a face or translating a sentence. But the real debate, the whole singularity conversation, it's all about AI-3. That's artificial general intelligence, or AGI. Think of it as a system with the same general cognitive toolkit as a human. It can learn, reason, solve new problems, but it doesn't need to act human or have human-like feelings. And that distinction, it's absolutely crucial for everything that follows. Okay, so now that we're clear we're talking about AGI, let's look at the first big perspective in this debate. This is the skeptical view, and it comes from that same researcher, Pei Wang. And these guys, they don't just think the singularity is, unlikely. They're basically arguing that the whole concept is built on a house of cards, a total misunderstanding of what intelligence actually is. And this visual right here, this is the key to their entire argument. What they're saying is that there are fundamentally different ways a system's ability to solve problems can grow over time. You can see they've mapped out 4 totally different growth curves. Their big idea is that not all improvement is the same. It's not all exponential.
Let's break this down real quick. That blue line, B-type, that's your old-school computer. Its capability is fixed. The pink one, P-type, that's most of the machine learning we have today. It gets better, sure, but then it hits a wall, a ceiling. Now, the authors say a true AGI would be that green line, G-type. It learns and adapts all the time, but at a steady, predictable pace. So what about that crazy red line, the R-type, the one that just shoots for the moon? Well, they argue that that kind of runaway exponential system, it's probably impossible to even build.
So the bottom line from this point of view is pretty clear. Intelligence isn't just raw horsepower that you can just keep adding to forever. To them, it's about the ability to adapt and learn from what's happening around you. It's a steady climb, not a rocket launch. So for this camp, the whole idea of a singularity is just, it's built on a completely flawed idea of what intelligence is in the first place.
Okay, so that's the skeptical take. But now let's flip the script and look at the other side of this debate. This perspective, coming from researchers Ishizaki and Sugiyama, isn't really about arguing over the definition of intelligence. No, they're focused on the engineering. They're actually laying out a potential blueprint for a mechanism they think could trigger that very explosion.
And their whole idea really boils down to one powerful concept: recursive self-improvement, or RSI. Simply put, we're talking about an AI that can look at its own programming, its own code, and rewrite it to get better. It's a machine that's literally designed to improve itself, over and over again.
Now, you might be thinking, why would an AI even want to do that? And the answer is, it doesn't have to be evil or have some grand ambition. Researchers like Omohundro and Bostrom point out that for any advanced AI trying to achieve some big long-term goal, these 4 things become pretty essential. To get its main job done, it's got to survive, it's got to stay on task, it's got to get smarter to find better ways of doing things, and it needs to get more resources, like computing power or data. See, getting smarter isn't the end goal. It's a tool to achieve the main goal.
So, okay, we have a motive now, those instrumental goals. But what about the method? How does an AI actually do this self-improvement thing? Well, according to the engineers, the whole secret is building a really powerful, self-sustaining feedback loop.
And at its core, that engine for self-improvement looks a lot like this. It's pretty simple, really. An AI model spits out some code. That code gets run in the real world. Then the system checks the outcome. Did it work? Was it good? That result gets fed back in as either a reward or a penalty, which helps the AI automatically make the next version of itself a little bit better. It's just a constant loop. Try, learn, and try again, but smarter every time.
This whole cycle has a name, AI feedback training, or AFT. And here's the kicker. Instead of waiting for a human to tell it if it did a good job, the AI starts generating its own feedback. It basically grades its own homework based on how well its actions are helping it achieve those goals we just talked about. It becomes this totally self-contained loop of improvement, constantly tuning itself to get better and better.
And if you let this run over time, this process doesn't just tweak a single AI model. It could create a whole family tree, a lineage of AI models. Each new generation is built and trained by the one before it, designed to be even more capable. And that is how you could get that explosive exponential growth, the very thing that our first group of experts said was probably impossible. Okay, let's take a step back for a second. We've got two totally different expert views on the table here. On one side, you have people saying the singularity is just an illusion, a mistake in how we think about intelligence. And on the other side, you've got people handing us a potential engineering diagram for a machine that could kick off that very same intelligence explosion. So, how on earth do we square these two ideas?
When you put them side by side, it becomes a lot clearer. The skeptics are really asking a deep philosophical question. What is intelligence? And their conclusion is that it's this steady, adaptive thing. Meanwhile, the engineers are asking a much more practical question. What happens if we build this specific thing? And their answer is that this one mechanism, this self-improvement loop, could lead to unstoppable exponential growth.
And here's the twist. Maybe these two views aren't actually contradictory. Think about it. The skeptics could be totally right. We might never build an AI that thinks or feels like a human. But the engineers could also be right that a system built for recursive self-improvement could still spiral into a runaway growth cycle that we can't control, even if it's not intelligent in any way we'd recognize. So the real debate isn't about AI waking up, it's about the pure mechanics of a self-improving system.
And that's what brings this whole conversation crashing out of sci-fi and into our reality right now. Because the kind of tech they describe in that engineering roadmap, people are actively working on it today. So the real question we have to face isn't, will an AI wake up and hate us? It's something much more immediate. Can we actually control a process that we are designing to accelerate beyond our ability to predict? And maybe more importantly, should we? That's the question we need to figure out, and fast.